My dear friends, we are having Rahul Kumar Sir, a passionate innovator in clean mobility with a BTech in mechanical engineering, in specialization is automobile, and MTech in defense technology. With 4 years of industry experience and over 2 years in EV education, he has contributed at the DRDO R&D Engineers Pune, working on advanced just a minute. Working on advanced defense mobility and battery systems, an expert in plug-in hybrid vehicle design and development, he has inspired students across leading universities to shape the future of the sustainable transportation. So today I welcome Rahul Kumar sir. He is our session in charge today. He has a lot of experience on the battery charging systems. So Sir Rahul sir, please take over and you can start presenting, sir.
Thank you, sir. Thank you so much. Thank you so much for the invitation, sir. Uh, so everyone, hello. First of all, I just wanted to say hello to all of you, and I hope you all are doing well. So in today's session, we will be actually diving a little bit into the charging standards of an electric vehicle or the entire EV ecosystem. So we will be just scratching the surface. We will definitely not go into the very depth of it because it's a whole, it's a very big aspect when we are talking about just the charging infrastructure. But I will make sure that in today's session, we will have little bit of understanding, and also the more we know about it, it's better that we will be able to share that with along with this particular group that we are having right now. So I believe in that only. So basically, yeah, whatever the knowledge I have, whatever I have seen into being an individual into the same industry and how the systems have been working. So I'll definitely try to share everything what I can with all of you. Right. So before starting towards it, I just want to know, does anybody here has any basic understanding of electric vehicle charging systems? Anything you can just tell me. Anyone? Hmm. Okay. Do we have anybody who knows about charging standards, not the standards, but the charging infrastructures? Anything? All right. So I guess we will be starting it from the very scratch only. So no issues. I will just start
हेलो
presenting my screen.
सर
Yes,
आप क्या
yes.
बोल रहे थे अभी ज्वाइन हुआ मैं
हाँ, मैं ये पूछ रहा हूँ, क्या आपको कोई भी इंफॉर्मेशन है अबाउट चार्जिंग स्टैंडर्ड्स, चार्जिंग इंफ्रास्ट्रक्चर ऑफ इलेक्ट्रिक व्हीकल्स? कुछ भी? कुछ भी आइडिया है?
आइडिया मतलब बेसिक आइडिया है सर उसको फास्ट चार्जिंग होती है स्लो चार्जिंग ऐसा चार्जिंग
हम्म
स्टेशन तो
हम्म
हमारे इधर भी एक है फोर व्हीलर और टू व्हीलर
हम्म
के
हम्म।
तो ऐसा अगर
और कुछ इसके बारे में पता है?
और इतना तो है मालूम
चलो, कोई इशू नहीं है. No issues. So we will be taking it from the very basics only, from the very beginning part only. So instead of showing you any of the uh, presentation, I will basically present and I will write it down everything for all of you so that it will be a better understanding. Because yeah, definitely I can show you a presentation, you can understand that as well, but it will be better if I'll write it down and make you understand each and every point. Right. So let me just share my screen. Is my screen visible?
यस सर
Okay, great. Great, great. Yeah. So let's start with the thing over here. All right. So we are here, we are gathered here to talk about charging systems. Okay. So we will be talking about charging systems in EVs. So before actually talking about charging systems, we need to understand what exactly charging systems are there and what all things we are using into this particular domain, right? So obviously, you are using mobile phones, okay? So mobile phones you are using, laptops you are using, multiple other gadgets you'll be using, all of those are are being charged with their specific chargers. And similarly, we have electric vehicles also. They would also need chargers. Okay. So in these chargers, what is the difference between let's say if you have a mobile phone which is charging at, let's say, 60 watt, okay, and a laptop which would be charging at 150 watt, right? So what is the difference between these kind of chargers and a charger that you get in your electric vehicle? So if I'll ask you that question, can you answer me that? Anyone? Okay, so I'll tell you, basically, if we talk about, the fundamental is same. How your mobile phone is being charged and how your electric vehicle is being charged, it is almost the same thing. The only difference that you'll be getting is the charging output. So here, with your mobile phone or laptop, the maximum charging output that you're getting is about 150 watt or 60 watt, right? But for EVs, for electric vehicles, we are getting the output in kilowatt. Okay, why? Because the batteries that you're using in your phones or laptops are also, monitored in watts. So probably your like the entire power of the battery would be measured in watts only, because it is not that big of a battery as well, right? It is very small. So that way it cannot be into kilowatts. But for our electric vehicles, yes, the batteries that we are using are measured into kilowatt hour, right? So that is why if I have a battery pack which is having at least 1000 watt, so 1000 watt will be 1 kilowatt, right? So when I have a battery pack which is having 1000 watts, so definitely this 60-watt charger will be taking a lot of time to charge it. If I divide 1000 by 60, you will know how much time it is going to take to charge, right? So, and that will be very, very, very slow. And that is something that we cannot afford in EVs. And that is why we have like a different altogether infrastructure for charging systems in electric vehicles. So I'll just explain you. So this charging system has been divided into three levels, which are level 1, level 2, and level 3. Okay. So in this one, level 1, this one is AC charging. Okay. AC maximum supporting up to 3.3 kilowatt. Okay. Then we have level 2, which is also AC, starting from 7.2 kilowatt going till 20. Okay. Then we have level 3. This is DC charging, starting from 30 kilowatt going up till 350 kilowatt. Right. So this is like the three levels that we are having in our charging infrastructure. Now, level 1 is slow charging. Level 2 is moderate. And level 3 is fast. Okay. So this is a major difference into our charging infrastructure that we are having currently in entire globe, not just India I'm talking about. This is
Sir,
globally I'm talking about. Yeah.
sir, for the level 3 charger, how much voltage is there? for the
It
DC charger?
depends. It depends. So it depends on the battery pack and what sort of cell chemistry that you are having into the battery pack. So let's say in level 3 charger, can I explain it a little later because it will be a little bit advanced version. So I'll
Okay, sir.
I'll just explain few things first and then I'll give you that.
Okay, sir.
Is that
Okay.
clear? Is that fine?
Okay, sir.
Actually, let's do one thing. I'll just explain you right now only. No issues. So basically, what happens with electric vehicles? So in our EVs, the batteries are having different C ratings. Okay. C rating is basically the charging and the discharging rating of each individual cell. Right. So it starts from 1C and goes up till 10C. Now we do have batteries which are actually going into 30C till 30C, but these are still not into production vehicles. The production vehicles that we are having maximum capacity of 10C's batteries, which are again very expensive. Now these 10C batteries are capable of charging themselves on an average of 100 kilowatt of charging output in 1 hour. Okay. And when the battery pack is charging at 100 kilowatt charging output, it will be consuming a voltage of around 800 volts, right? So now, if your DC fast charger can deliver 100 kilowatt, then it will be operating at somewhere from 600 to 800 volts. Now, this voltage is dependent on the kind of battery that you are using. Either it will be 1C battery, 2C, 3C, or 10C. Right. So this is how basically the voltage bifurcation is happening. And if the charger is delivering less than 100 kilowatt charging output, then the maximum voltage it touches is till 600 volts, and the range is 350 to 600 volt. So let's say if the battery is being charged from a 30 kilowatt charger, then in that case it will be having 350 volts. That is the max voltage that the battery is being charged at. And if the same charger is delivering, let's say, up to 60 or maybe 80 kilowatt of charging output, then it can go up till 600 volts. Right. And then when we reach to 100 kilowatt, so the maximum, like the biggest charger that we have in India is 180 kilowatt. Okay, we do not have any infrastructure which is suitable enough to actually be compatible with a charger which is having more than 180 kilowatt of output, right? So the infrastructure that we have in India is sufficient till 180 kilowatt. So that way the maximum voltage that we will be reaching will be starting from 600 volt, right? The 800 volt will not still reach at 180 kilowatt. 800 volt will be reaching at somewhere around 250 or 250 kilowatt or 300 kilowatt, right? So in this case also we will be cruising about 620, 700 voltage or something like that. Right. So this is basically what happens in DC fast chargers. Is that clear?
Yes, sir.
Yeah, there's a lot of different parameters that you need to also keep in mind, which are basically related to batteries. Okay, and how the battery has been reacting and how the BMS is actually calibrated to charge the battery itself. Like there are batteries which are having good number of charging discharging cycles and good energy density also, but still they are being charged very slowly because the BMS has been programmed in such a way that it will be only giving you out the maximum range possible. Right. On the other hand, similar kind of battery will be delivering you very minimal range, but it will be delivering you very high performances. Why? Because the BMS is programmed like that. So there are so many parameters that you need to understand before actually getting into it. And there's also one more thing that I want to talk about is if we are talking about automotive domain, right, and specifically in EVs, if we are dealing in, I cannot say that there will be any of the sector which is independent. None of the sector, none of the domain is independent. Each and every sector is dependent on one another. If currently we are talking about charging systems, we have to talk about battery and BMS. We have to talk about the structure that the how the vehicle structure has been formed. We have to talk about where the battery placement has to be. We have to talk about what would be the BTMS system of the vehicle, battery thermal management system, right? So all of these we have to talk about. Otherwise, we will not be able to get to a conclusion, after this conversation. So we have to understand that all of these things are interconnected, right? Now, coming back to our thing, as I've mentioned that we have three levels of charging, which is level one, level two, and level three. And the charging outputs also I have explained to you, right? So when we are talking about, let's say, AC charger. So this is for sure, you know that we have two different types of chargers. We have AC and we have DC, right? So how these AC chargers are working, how these DC chargers are working. So we need to understand that also. So first I will be explaining you AC. Now, why and how we are using AC? First of all, using AC is very, very, very easy. Why? Because obviously, this is how we've been dealing with the entire energy, like the consumption thing for any kind of application. If you are using it at your home or your commercial space, your industries, factories, anywhere you go, you will find AC connection, right? And that is the load of that is varies from different area. Now if we already have AC infrastructure, so we would also want to charge our vehicles using AC, right? But the only point is the vehicles are having batteries, and batteries are DC source. They cannot be charged with AC unless we will put a converter in between, right, which will convert AC to DC, right? So now, the manufacturers, the innovators decided that since we have the infrastructure which is suitable or compatible with AC only, so we will try to use that only, and we will also put a converter in between. Okay, so that converter that we are talking about is actually nowadays called as OBC, which is onboard charger. Okay, so this OBC or onboard charger is always present in your EV four-wheeler. Now, mind you, one thing, I am currently talking about four-wheelers and bigger segment. I am not going into two-wheelers right now because there are so many two-wheelers, so, like a very big chunk of segment is still not using onboard chargers. Okay, so I am not going into that. I am currently talking about the four-wheelers and the variants which are above than that, right? So in each four-wheeler, you will find an onboard charger. Now, what does this onboard charger do? And how is it different from the like the socket and the wall that we like the wall charger and the socket that we the company has provided to you for charging of the vehicle, right? So let me show you something. Let me just type it. Let me give you a quick. You see, this is the kind of charger. This is the kind of charger you get with your vehicle when you buy the vehicle, right? So I'll show you, let's say I'll give you like real example, Tata charger, I will show it to you. So you see, this is the kind of charger you will be getting along with your vehicle. Be it you are getting, let's say, Nexon EV, Curve EV, Tigor, Tiago, Punch, any of the vehicle that you go for, you will get this portable charger along with the vehicle. Now, this is just one wall-mounted, this entity, and then we have a charging gun, and rest we have these cables. right? So how we are charging the vehicle with this one? Now the question is that, and how do we do that? Basically, the wall-mounted setup that you have seen is nothing but it is used for energy regulation or stabilization and fault detection, right? The unit that wall-mounted unit you have seen, the only work it is having is energy stabilization regulation and fault detection. If there will be any fault, it will automatically cut off the charging. Rest, everything happens through this onboard charger. So I'll basically make a diagram over here to make you understand how charging happens in AC charging setup. So first of all, obviously we have a wall socket. Okay, so with wall socket, your portable charger, I am writing as PC, the one that I have showed to you is connected, and that PC is connected to OBC. Okay, in OBC is further divided into two parts. These two parts are one is conversion, okay, the other one is PFC. So this PFC is known as power factor correction. Okay, that means whatever the losses there have been while the conversion process was happening, at that point, after like obviously into this conversion process, what obviously it is a converter. There will be rectifiers over here which will be converting AC into DC. So while obviously the AC that we are getting is this, right? And DC that we need is this. Right. So we will definitely have losses from coming here to here. So those losses has to be fulfilled and those losses has to be covered through this particular unit, which is called power factor correction. It has like the step up or step down transformers also for DC, and it will also increase or decrease the current with the help of capacitors. Right. So that way it will boost up the voltage, the lost voltage, and it will also boost up the current with the required current, right? Now, once this is done, the output goes towards the BMS, right? In BMS, there is one specific part which is called AFE. Okay, I'll write it down. What does that mean? This means analog front end. Sorry, this is end D. Okay, so once the output from PFC goes to BMS, it will check if the voltage is fine, it will check if the current capacity is fine, and then it will give to the battery. Now, this is the entire power flow in terms of an onboard charger or when you are charging your vehicle through AC. Now you see the power is coming from wall socket and it is going here. But you see how many different divisions are here. So definitely the power will be lost, right? So that those losses has to be covered also, and those losses has to be keep in mind while you are calculating the charging time as well. Right. And that is why we have like with AC chargers with these wall mounted hanging chargers that we get from OEMs along with the vehicle are taking so much time to charge the vehicle. The downtime is a lot. So that is the one thing that you need to understand with AC chargers. Yes, because the conversion and the entire flow is taking a lot involving a lot of different modules. So that ways there will be losses, and if there will be losses, definitely you will be charging the battery at a slower rate. Right. This is one of the reason why we are like why the AC charging is slowing. Now, this whole setup is till 3.3 or 3.2 kilowatt charging output. Right. Now here I will again show another picture to you. Now you see this one. This one is an AC charger, but 7.2 kilowatt charger, which comes from Tata. Right. So this one is also similar to the one that we were already having, but this works on three phase. First of all, the earlier one only works on single phase. Right. The major difference is this, and as we have increased the phases, the charging output has gone up as well. That means the earlier one can maximum charge the vehicle with maximum output of 3.2 kilowatt. But here, just a second, let me add another page. Yeah. So these 7.2 kilowatt chargers are now into three phase. Okay. So three phase are actually coming into level 2 charging. Okay. Three phase has gone into level 2, and this can go up till from 7 to 20 kilowatt. Okay. That means that battery can be charged at a very faster rate. The only thing, like obviously, the downtime will be there when the conversion will be happening. Apart from that, there will be no other downtime. And the route it will be taking, that route has to be same. From wall socket will be now the entire charging unit will be there. Then from that, this portable charger will be replaced. This wall socket will also be replaced. This will be grid, because this will be connected directly to the grid, and this after that this portable charger will be converted into charger itself only, and then the rest of the process will be same. It will connect with OBC. Onboard charger will do the conversion. It will also do the power factor correction, and then it will give to the BMS. From AFE it will be going to the battery. Now the rest of the process will be same for it. Now this is how basically it is differing in level 1 and level 2. Level 1 is only till the maximum amount, maximum charging output will be 3.2 or 3.3 kilowatt hour. Let's say if you have to go more than that, then in that case, you'll have to convert to three phase only. Otherwise, it will be not possible. Right. Now we talk about, now we talk about DC. Yeah, so in DC chargers, as I've mentioned, that they are going from 30 kilowatt to 350 kilowatt, right? But this 350 kilowatt is now surpassed. It has been surpassed now. The maximum DC charging output that you can achieve from a charger is 1.6 megawatt. So 1.6 megawatt is 1600 kilowatt, right? So earlier, 3 months, not exactly three, yeah, exactly 4 to 5 months back, we were maximum till 350 kilowatt chargers. But in last 5 6 months, the biggest charger that we have is 1.6 megawatt by a company called DD, DIDI, which is China based. Okay. Then we have another company which is actually getting another charger which is slightly lower than this one. It is 1.4 megawatt. This is by Huawei. This is a phone, this used to be a phone company. Obviously, again, this is also China based, right? And before two of these companies, there is a very famous company which actually started this megawatt journey of chargers. They started with their 1 megawatt charger, and the name of the company is BYD. And you know the origin of the BYD is again Chinese. So these three Chinese manufacturers, BYD, Huawei, and DD, they are currently 15 to 20 years ahead into the charging technologies, right? So the 350 kilowatt chargers were also actually used to come by with the only company that it was creating was Tesla. And below than that, we have chargers from multiple companies which are maxing out till 300 kilowatt. Rest of the companies that are currently there in entire globe or India, they are getting the maximum they are getting the maximum charging output of 300 kilowatt only. The 350 kilowatt charger used to be the Tesla super fast charger or supercharger that we used to call it, right? That has been surpassed now with 1 megawatt charger of BYD, 1.4 megawatt charger of Huawei, and 1.6 megawatt charger of DD. Right. But the only thing is, all three of these are currently exclusive to China. And if I talk about the global extension, then in that case, still Tesla is still having the highest charging capabilities. Right. So that way Tesla is still leading, but it will take hardly 1 or 2 more years till these particular technologies will come out and it will they will be exposed to the other nations as well. And then Tesla will be lacking behind. Right. So this is how this whole entire DC charging systems take place. Now, we have talked about the infrastructure. Now we will talk about the charging differences. Here I have given you the entire path of the power, how from where and how it will be flowing and how it will be charging a battery. Now I will also give you same comparison for DC also. Now here, what is happening? So first of all, you have a grid. Okay, that grid is connected to the charger, or you can say the charger is connected to the grid. Inside your charger, you have there are multiple things that you have inside the charger, which is obviously first the conversion. Okay, then we have PFC, power factor correction. Then later on, we have thermal management and communication. Comms, I'm writing down as comms, right? So inside the charger, you have all these modules. Then the charger is connected with the vehicle. Okay, so vehicle. Inside that, the charger will be connected with the VCU. VCU is connected with the BMS and BMS with battery. Okay. Now here, this is directly connected here. From vehicle to battery, it is going. The VCU and the BMS are actually connected in a loop where the main power is not going, only the communication has been established. Now, I'll tell you one thing, what is happening over here. From grid, you are getting AC. Okay, that AC is being converted into DC inside the charger itself, and it is also being the power factor of that is also being corrected over here, and it is also making sure if the thermal management of the system, the entire charger and the vehicle is in a good condition or not. Otherwise, it will not start the charging actions. Now, once every condition is satisfied, it will directly connect with the BMS and it will be charging the battery. Now, why do we have VCU over here? The main reason of VCU is because the VCU is directly connected, sorry, the VCU is directly connected to the charger in terms of getting to know the vehicle aspect. So what is vehicle aspect here is battery information. Battery information it will be having. And what exactly in that battery info in that? First of all, SOC, SOH, SOT, okay. Then charging cycles, okay. And rest part, what do we have? There's one more thing, which is SOC, SOH, SOT, charging cycles. And yeah, maximum, max voltage and current. I'm just writing I over here. Okay. So maximum charging current and voltage. So all of these information has to be catered to the charger earlier, like beforehand only, before you connect the charger. Like obviously when you once you connect the charger, all of these information has to first deliver to the charger. And according to that, the charger will make sure how much voltage, how much current it has to provide to the vehicle so that the vehicle will charge at a faster rate as well as in a safer manner, right? That is why the VCU is connected with the charger. Now, how it is connected? It is connected through a port. It is connected through a port. That port is called uh, CP, which is known as uh, control pilot. Okay, this control pilot is actually there to establish the communication between your charger and the VCU. And how VCU is getting all of these information because VCU is directly connected to the BMS. Now, BMS is already having all the information about the battery, what is the exact size of the battery, how many cells are there, each individual cell is having what kind of voltages, what kind of current capacities, and what is the entire pack SOC at that particular point, what is the state of health of the battery pack, what is the temperature of the entire battery pack, and how many charging cycles have gone by till now. So all of these information will be having with BMS and VCU will be retrieving those information and giving it to the charger. Now, this whole process is coming under a protocol, which is known as OCPP, which is Open Charging Point Protocol. Okay. So the Open Charging Point Protocol was actually established to make sure that the each individual charger that is present in any of the locality, if it is commercial, if it is residential, if it is private or anything. So in that way, it has to be connected with any sort of vehicle and charge the vehicle. Just like that, the thing that we are having with petrol vehicles, you can we have multiple petrol we have multiple companies which are dealing with petrol and diesel. We have Indian Oil, we have Bharat Petroleum, we have HP, we have Geo, we have Reliance and all. So, but you go to any of the petrol pump, you fill your tank with petrol or diesel, and you just pay, and that is it, right? That it is not like that. Companies like the Tata has to get the petrol from Geo pumps only, or the Indian Oil pumps only, or Mahindra has to get the petrol pump from the Adani pumps only. It's not like that, right? You can fill your tank from any of the petrol pumps. Similar is the case with the charging points, charging stations. So doesn't matter which different company is making the charger. or which company's vehicle that you are using at this point, it has to be connected with each individual charger and it has to charge the vehicle. Yeah, you can definitely cap the charging output. That is, let's say there is, I'll give you an example. Let's say we have an example of Adani. Okay, so Adani Group has established their charging stations. So they are providing either 30 kilowatt or 60 kilowatt charger. Now, few of the companies are already in tie up with Adani. So for those companies, they can maximum provide 60 kilowatt of charging output. But the companies which are not connected with Adani or not having any sort of MOU understanding or maybe some tie-up. So in that case, the same charger will maximum only provide 30 kilowatt of output, which is still not very less, but not too high as well. In this case, definitely, if the vehicle is taking for slow charging, the vehicle will be taking anywhere between 8 to 10 hours to charge. With 30 kilowatt, it will be charged in maximum of 2 to 3 hours. So that way, it's not like that you are stranded completely. Yes, the wait time is still there, but you are still able to manage that thing. That means the vehicle should be charged. Rest of the things can be taken care of. Right. So yeah, this is something that is happening right now also. But if we leave it apart and if we see if this whole Adani systems are following or maybe adhering to the open charging point protocol, yes, they are, right? Because they are letting other vehicles to charge at their stations, right? That means everybody is getting the like the charging that they require. Right. So this is a little bit about the chargers. Now, obviously, there are different segments of charging as well. If we go into that, so like just a second, guys. Yeah. So everything that we have talked about are majorly in wired chargers that we are having. Okay. Then we have two more different scenarios in charging only, which is one is battery swapping, the other one is wireless, right? So we have two more technologies, which is battery swapping and wireless charging. So very interesting concept for both of these. Currently, if I talk about India, this battery swapping is actually doing wonders, but for one specific category, which is first of all EV two-wheelers, two slash three-wheelers, and what is the specific category is quick commerce and fleet. Right. So when we're talking about, let's say, these Instamart, Swiggy Instamart, Blinkit, or Zepto and all. So at this point, all of these companies are connected through, are either directly connected or somewhere connected with the companies which are providing them two-wheelers, electric two-wheelers on subscription model or maybe on the lease model. And these two-wheelers have been used by the delivery partners, and they are charging like these companies are charging the delivery partners about, let's say, 150 rupees or something like that per day, and each individual battery they are charging about 100 rupees a pack. Okay. And let's say in each individual pack, the delivery rider is almost around covering about 55 to 60 kilometers of range. So that way, let's say a complete delivery partner is taking 20 to 30 different orders in an entire day, and the complete distance it is traveling in each individual order is about 3 to 5 kilometers. So that ways, even if he is getting 50, like 20 different orders in an entire day, that will be around 100 kilometers. Right. And the pack that he is getting is actually giving him the maximum amount of energy up till 60 kilometers. So that way he's still shorting about 40 kilometers. So that has to be, again, first of all, he cannot afford the downtime. Downtime is when the vehicle has to be charged. Okay. And secondly, if he has to go through the entire process, then in this case, he will be losing out on the money, he will be losing out on the opportunity that he has to get. So that way, these companies came up with a solution that they will be providing them, providing these particular vehicle riders charge batteries in some amount. Okay, so they have decided to charge their batteries at their particular, sorry, at their particular facilities, and give the batteries as a subscription, and take each individual battery at 100 rupees or maybe 120 rupees per pack. So that way, if the rider was actually traveling 100 kilometers, so for 100 kilometers, how much he has paid? 100, 200 rupees. So 100 for one battery and the other 100 for this another battery. Now 200 rupees was for 100 kilometer. Is it enough? Is it good? Is it bad? Right now the math is a little bad. But remember, even after covering 40 kilometers, the remaining 40 kilometers here, it will be still having 20 to 30 kilometers of another run. So that ways, actually, it is getting about 220 to 230 kilometers in 200 rupees, which is coming out more than, like, not more than 1.2 rupees per kilometers and so. Right. So that way, yes, that way it is very much good. Right. So now if we talk about, let's say, uh, this entire process, how much downtime is having over here? The maximum downtime in swapping or replacing a discharged battery with the charged one takes maximum of 5 to 10 minutes. This is, I am talking about on a very busy day when you have a lot of people coming in and there are problems and all, a lot of different things that are happening. At that point, the maximum that you can get is 5 to 10 minutes. But when we talk about, like, what is the average time, it is just 3 minutes max. Okay, so the downtime was just 3 minutes. That way, the EV delivery partner is not stopping. He has the good amount of range also, and he is able to get through all the orders that he has got, right? Which is something commendable for him, right? So this is how battery swapping has been contributing into this entire charging infrastructure. Then similarly, we have wireless charging also. Okay, wireless is obviously you have seen wireless charging first in mobile phones. Okay, so what do we have there? We have one transfer coil, one receiver coil. Okay, then this receiver coil will be having one PFC, and then that PFC is connected to the BMS and battery. Okay, and here this transfer coil is connected to the grid. Okay, so what is actually happening? So this transfer coil is generally placed on the ground. Okay, and through the ground only the wires will be going to the grid, and this transfer coil is connected through the ground grid, and this has to be resonated. These has to be resonated, like vibrated at a very, very higher capacities. Like the frequency and the modulation of that is very, very high, which is not visible to the naked eye, and not like we cannot also feel that, because our human body is not able to feel those or receive those. Then in that case, due to the resonating phenomena, there will be an EMI, electromagnetic induction, will be influenced, and through that, whatever the like charging we are be getting from the grid, whatever the power that we are getting from the grid will be transferred using this transfer coil, and received at the vehicle end through this receiver coil, because this receiver coil will be connected, or I would say implemented in the base of the vehicle. And once it is received, that whatever the energy that we have received from the transfer coil has to be going through this PFC module, which where the voltage and the current has to be increased according to the minimum limits of the battery pack charging, and then it will be going to the BMS and battery, and that is how it will charge the battery. Now, this entire process is look very, very futuristic, but it is not efficient. At least it is not efficient right now. The maximum efficiency that you can get out of this is about 40 to 60%. That means if the grid is providing you, let's say 1 kilowatt, right? In 100% efficiency, you would be charging the vehicle at 1 kilowatt, right? But here you are taking 1 kilowatt from the grid, and you are only been utilizing 500 watts or zero point 0.5 kilowatt. So rest of the energy is actually being lost in this entire process. So that way the efficiency is very, very less in it. And if on the other hand, if we talk about the efficiency for the wired charging system, there the efficiency is about ranging from 85 to 95%. So if I have a complete efficiency of 85 to 95%, let's say taken like average of 90% only. So in that 90% efficiency, definitely I would definitely go for a wired charging, because this way, like obviously, if I'm charging my vehicle, either let's say 30 kilowatt output as well. So maximum my vehicle would be charging at, let's say, 15 to 18 kilowatt output, which is comparatively less. And if this same thing I will be charging with the wired charger, at that point, my vehicle would be charging at, let's say, 29.5 or maybe 28 kilowatt hour. So at that point, definitely the charging time of wired is less and wireless will be higher. So why would I increase my downtime? Let's say I'll have to like right now I am on a road trip, and I want to reach to a location very soon. So in that case, I cannot afford that downtime, right? So I will definitely go for a wired charger. So that is one of the thing why we do have wireless charging options available in India also. Currently not commercially, like not for everybody, but in the R&D phases. But you can see the wireless charging scenario in like more 7 8 months, or maybe within a year, because Ola has, like last month only they have launched their wireless charging setups last month on 16th, or sorry, 15th of August, right? So you might be seeing those into their experience centers, or maybe they will set up some of the already existing charging stations only. So you might see that there. But for four-wheelers, yeah, there are very few companies which are actually working into this same profession, right? So yeah, this was a little bit about chargers. So if I will just give go back and give you a brief about the entire session that we have just talked about. So I'll just tell you what we have started with. We have basically started with levels of charging. So, first of all, we have two different types of charging, which is AC and DC. Then in that, we have talked about levels of charging, level 1, 2, 3. Level 1 and 2 having AC, level 3 is DC. The output of level 1 is maximum 3.3 kilowatt, level 2 ranging from 7.2 to 20 kilowatt, and level 3 ranging from 30 kilowatt to 350 kilowatt. Then we talked about a little bit about the C rating of the batteries, right? And the difference between voltages for different output of DC fast chargers. Then we went into the onboard chargers, how onboard chargers work, and what is the exact power flow system of onboard chargers. So that we have talked about. And similar thing we have seen into three phase, that is for level 2. And then we also talked about the power flow of DC, right? So how DC has been charging and all. We talked about one of the charging protocol, which is very, very important, open charging protocol, OCPP, and a little bit about battery swapping and wireless technology. So if I sum everything here, so this is something that I have like barely scratched the surface. Now we have a lot of other things inside it also. But if I talk about, let's say, if you have to talk to anybody or maybe have a conversation regarding the charging systems, you have enough of the content there where you can definitely, start with, and you can also do your own research on it and gather data, and then, move ahead with the same, domain. But still, you are still like, if you have got, let's say, how much I have given, let's say 100%. So even if you have listened and grasped 60-70% also, that is still a lot of knowledge that you are having currently, in terms of, let's say, if you compare yourself with any of the person who is out there, even they are using electric vehicle as their owners, right? So yeah, this is pretty much it for the session. So I would want to ask questions if you guys, anybody having any questions, any doubts in it. So I am open to that. You can just let me know. Anybody having any questions, any doubts?
So for two wheelers also, this chargers are coming.
Sorry, can you speak a little louder?
Hello, am I audible?
Yeah, you're audible. Yes, yes.
Sir, for two wheelers, you said that Ola has been released recently.
Mm-hmm.
So for
Yeah.
two wheelers also we have.
I'll tell you. So for two-wheelers, there are only few players which are actually going into the standards of charging, which is obviously one is Ola, then we have Ather, and then we have TVS. Okay, rest the companies that we are having, let's say Bajaj and all, and even if we remove Bajaj from the equation right now, we have mostly the companies which are directly get sourcing their vehicles from China, or maybe still assembling the vehicles here, and the whole ecosystem is developed in China only. So that is one of the reason why two-wheelers are still not getting into fast charging systems, or maybe the charging systems, like they are still not following this open charging point protocol and in entirety. So that is why you can see like you cannot charge your Ola vehicle with the Ather charger.
And moreover, I think two-wheeler has only AC charging, no DC fast charging.
Yes, two-wheelers doesn't have DC fast charging, they only have AC charging.
AC
So,
charging,
Okay.
AC charging. Ola has also introduced at hypervisor AC charger points, where the charging speed is somewhat better than the home charging. Is it right, sir?
yes, yes, sir. So at those points, the charging capacity is up till 3 kilowatt. right? And the charger that Ola provides with the vehicle itself is maximum of 900 watts. So you are
So how
charging
much
the
time it
vehicle
takes,
three
sir?
times
How much
faster.
time will it takes? How much time
Sir,
it takes, sir? Yet.
it basically decrease the times three times, like decrease the whole charging time by three. So basically, let's say if your battery was charging in an average of 7 to 8 hours, now it would be charging completely in 1.5 hours maximum.
At that point, at the Ola point, right?
Yes, 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 at the Ola points.
Okay, okay,
Sir,
okay, sir.
how much battery can charge like in percentile or in a safest way?
To get into this particular question, you'll have to get into the battery technology, and like in that also, you have to get into two specific things, which is C rating of the battery and thermal management of the battery. What is the thermal runaway of the battery? So, if I
Yes.
have also mentioned about the C ratings. Let's say if your battery pack is having one C, so
Okay.
the that particular battery pack, that individual cell, can be charged up till of 50 kilowatt direct charging, and it can discharge also at that same rate, right? Similarly, like the amount of C rating will be moving ahead, like it is going from 1C to 10C. This rate will be going above, like it will be increasing from that point only. Right. So that is something happens in charging. Like right now, if you cannot define what is the entire battery pack that you're having, you cannot know the exact values of charging input that they can have.
So like EV charger is charged vehicle like up to 100% or less than that?
It actually charges the vehicle, like it will show you in the vehicle system that the vehicle is charged 100% only, but the
But
vehicle is always
physically,
charged around 95 to 97%. It is never charged 100%.
okay, and the charger will cut off automatically.
Yeah, the charger will cut off automatically.
Okay.
Because 100% lithium is like bomb, sir. You are carrying bomb with
Yes.
you.
Yes, yes.
That's
It will
right.
be very unstable at that point. And let's
Yes.
say if there will be 1 or 2 minutes of overcharging condition, in that case, it will be
Deployed.
reacting in a very, very miserable way.
Okay. Yes, sir.
Yes, yes.
So it will be exploited.
I
Yes,
would
yes, it
not
will
say it
explode.
will explode. See, the new batteries that we are having, they are still explosion free, but still you will be having some kind of leakages, or maybe the thermal runaway of those
Thermal
battery will
runaway.
become very high. So it will cause a lot of problem. Even if they will not explode, you will definitely see that these batteries will catch fire.
Okay.
Yeah.
Yeah,
Thank you, sir.
no issues. Any other questions that anybody is having?
So thank you very much, Rahul sir, for participating in our session. It's a very beautiful experience of knowing the latest technology. So I thought better you should get involved in this session, because you can give the updated on-hand information of how the technology, because you have been going through this for the last 5 to 6 years. It's
Yes,
really a
yes.
wonderful session, sir. We have really enjoyed a lot. But I request you, sir, next week I will anyway take the session. Third week, again, I will request you, sir, to come and discuss about the power distribution unit, state of charge, state of health, depth of discharge, these parameters concerned to battery, how to calculate, what are all the methods, mostly on the power distribution unit, sir, because that is the heart of entire electric vehicle system. So I request you, sir, to please come again in the third week and deliver the valuable content to our friends, sir. So I thank you very much, sir, on behalf of all my students and friends. I can say friends, sir, because most of them are very senior level working professionals. They have a lot
Yes.
of interest on these emerging technologies, and we are very fortunate to have you, sir, for this session. And we look forward for you again in the third week of October to discuss extensively on this battery system, sir. Thank you, sir.
Sure,
Thank you very
sure,
much.
sure.
My dear friends,
Thank you.
are there any doubts? Shall we close this session? My dear friends, is it
Yes.
fine?
Yes, sir.
Please
Yes, sir.
please raise your hand. Please raise your hand in applause to our sir, Bosle sir. Thank you very much. Please raise your hand in support of, yes, sir. Thank you, sir.
Thank you.
Srinivas sir,
Thank you.
for Vaishnav Sonwane sir. Thank you, sir. Thank you very much for participating in this wonderful session. We will meet next week, sir. Same time, 7 to 8, and
Sure, sir. Sure, sure.
we will also have our Rahul sir coming back in the third week of October. Thank you, sir. Now the session is closed. Thank you very much. Good night. Happy weekend.
Thank you.
We'll meet
Thank you,
next
sir.
week. Thank you, sir. Thank you very much. Thank you, Rahul
Thank you,
sir.
sir.
Bye,
Thank you
sir.
so much. Okay, sir.
Okay, bye.